All right. Good day, everyone. Good morning, good evening, wherever you are. Welcome to the October 2025 Coffee Talk. My name is Vince Lecour. I'm the president of the International Society for Geomorphometry, following Hannes, who's in the crowd right now. I'll start with a quick introduction. If it's your first time joining us, the ISG, the International Society for Geomorphometry, is a non-commercial, non-governmental association of researchers and experts that encourages the free exchange of knowledge and opinions about various aspects of the processing of digital elevation models. Our goals are to improve the understanding of the properties of the land surface as analyzed quantitatively from the EMs and from digital and paper maps. Second goal is to advance the techniques used in the land surface or terrain analysis. We also want to foster international collaboration in the quantitative analysis of the land surface. And finally, we want to facilitate communication between scientists and students. We want to advertise relevant conferences and make public domain data sets and scientific papers widely available. So that's why we have those coffee talks. If you want to engage with our society, if it's the first time you join us, every 2 years we have a conference. This year in 2025, it was held in Perugia in Italy. And we'll have another one in 2027 in the Netherlands. We also are organizing different sessions at relevant conferences. So for example, the EGU, the AGU, and if you'd like to host a little ISG event at another meeting, you're always welcome to send out the invitation to our group. We're trying to have a virtual online presence. So here you see our different Twitter handle, Instagram. We have a YouTube channel where we post the recordings of those coffee talks. We also have a Zenodo community where we share data and papers, and we have those coffee talks every 2 months. So what are those coffee talks? They are public meetings that we organize virtually between our main biannual conferences. The aim here is really to discuss, exchange, initiate, present, outline topics, showcase research agendas, papers, questions. So they are relatively informal. We have a maximum of 1 hour. It's a 15 to 20 minute presentation by our guest speaker, then followed by respectful and open exchange or discussion. So we really want to encourage that discussion. And then we wrap up and we ask you to please promote these events locally and in your network, as we want to gather as many people as possible to these meetings. So I'll now let our main event start. So I'll ask our speaker to share his screen, please.
And I'll share my screen. Can you see my screen?
Yes, we see it just fine.
Okay.
All right, you can go ahead. Thank you.
Okay. My turn now. Okay. Good morning, good afternoon, and good evening. This is Li Yangxiong from Nanjing Normal University. Thanks for the invitation. This is my great honor to be here to show you about our work by this platform that is the Geomorphometry Coffee Talks. And I would like to introduce my topic, which is lesson research progress in geomorphometry in China. Actually, the NNU have a big group. We have 5 teachers, and we have more than 10 PhD students and more than 30 master students. But back to my talk, the outline of my talk contains 3 main parts. First is background. About the background, the first question I want to ask is why in China in my talk. Maybe some of you know, but I would like to emphasize that China should be an ideal area for geomorphometry research. This is because over 30% of the land in China are mountains, and there are 3 typical plateaus which attract many scholars to conduct terrain-related research. There are the lowest plateau, which is the most severe soil erosion area in the world, and the typical plateau with the highest area in the world, and the Yunnan Guizhou Plateau, which is the most typical karst landform in the world. So the topography in this area greatly affects their climate model, hydrological process, and the soil property, and so on. Thus, the terrain should be one of the major driving factors affect the occurrence and progression of the Earth surface process in China. And the second question is why me and why NAU? Actually, from just my views, there are five big research teams related to geomorphometry in China. There are Beijing team from Chinese Academy of Science, and also Xi'an team from Northwest University, and the Nanjing team from Nanjing Normal University, and also Shanghai team and the Wuhan team. And each team has their own geomorphometry research direction with representative scholars like Professor Cheng Ziqin from Chinese Academy of Science, whose research direction is watershed modeling. While in NNU or Nanjing Normal University, we focused on geomorphometry research direction of morphodynamics and GIS based on Loess landform investigation. And also in NAU, maybe some of you know, or some of you didn't know that 2 times of geomorphometry conference were held here. That is in 2006 and 2013. See these 2 group photos. Maybe some of you, you can find your younger smile face 20 years ago. This information can be found in the geomorphometry website. Now, all this information makes NAU be a special place for geomorphometry research. So back to my topic, we all know that the geomorphometry is also termed as DTA, is the science of digital terrain modeling and quantitative land surface analysis. Thus, in geomorphometry research, we need model the surface morphology, and also we need to analyze this model surface morphology in order to achieve a more important geoinformation and the knowledge. By now, it is widely accepted that the technique of DTA by using DM have been widely used to map the Earth's surface, characterize the topographic environment, and derive the attributes, and analyze the surface process. So as a science of measuring the Earth's surface shapes and their effects or process, geomorphometry has become one of the most important aspects in Earth science research. However, there are new problems and requirements in the research of geomorphometry. The first is we need more accurate and suitable data. And second, we need more advanced and efficient terrain analysis methods. And also we need more scientific and reasonable application cases. So with these problems and requirements come to the research progress. So the research progress can be mainly divided into 3 main parts: terrain modeling theory, terrain analysis method, and the terrain application. For the first one, actually, with the digital Earth requirement in China, the government has conducted the project of NSDI, that is the National Spatial Data Infrastructure. In this NSDI, the raster DM data were constructed from the contours with different cell size. For instance, the 10,000 scale of contour were used to interpret the 5 meter cell size DM. Thus, different scales of grid DMs were interpreted from contours. But there's a big problem in this interpolation process. That is the detailed information of the surface morphology was smooth. See this figure. Even the 5 meters DM, the detailed information of the terrace or the gully boundary was smooth and even lost when compared with the image information. Thus, we propose an FDM theory. The FDM called feature embodied digital elevation model. So in this FDM, we acquire the information like terrace and check them first from the land use data or image, and then we inverted this information into the DM. Then we can see this high fidelity terrain was modeled. The information of the gully shoulder line or terrace or check dams were concerned in this DM theory in the Loess area. And also we expand it into other areas like Clear. The second theory is the word filling of DM. Recently, we all know that there are several open free DM that we can download it globally, like ALOS, SRTM. However, there's a big problem in this data. That is, many voids exist in them. These voids are caused by shadows, clouds, or vegetations. So the first thing we need to deal with this data is voice feeling. Maybe some of you do not realize the voice. This is because someone has already felt this voice by interpretation or other method before you download them. And in this aspect, we have proposed a method of integrating technology into deep learning. Why is this idea? This is because we believe the technology can be transformed into rules that can be modeled, just like last century with several control points or feature lines. We can transform our technology into rulers and then construct the contour map. Remember that we cannot directly use using interpolation algorithm to fill this void. This is because the knowledge from the interpolation function does not necessarily imply that it is a Terran knowledge. So what are the Terran knowledges? As a scholar of geomorphometry, I believe in our mind, we know that we have the spatial morphology knowledge, like relief or roughness or curvature, but we also have talent feature knowledge or talent spatial relationship knowledge or morphodynamic knowledge and scale variation knowledge. But the question is, how can we use this knowledge or select some of them in talent modeling? So during this world feeling process, the first thing we need to is judge is that where are these words? Actually, this is the spatial relationship knowledge of location. If the words are located near the ridge line or the valley line, then we can further combine it with the talent feature knowledge. And whether these words are located in the convex part or concave part, that is the spatial morphology knowledge. With all these knowledges, then we can design different loss functions in the deep learning approach. So in this research, we have set 6 different loss functions. Function 1 is the original loss function of CGAM, and functions 4 and 5, which are used for emphasizing the accuracy of elevation at each location. These 3 functions are designed for the elevation. In addition, we also have another 3 functions for talent relief. They are function 2 and 6, which are used for emphasizing the talent relief along the ridge line, like ridges and valleys, and function 3, which are used for emphasizing the slope shape along the feature lines. With all these 6 designed loss functions as talent knowledge, the void will be filled with the deep learning process. With this approach, the results show that our method have a high accuracy compared with existing approach. And this paper has been published in ISE. And we also believe this method can also be expanded to other mountainous areas with voice. And the data can be updated fast and by using existing data, which makes a full consideration of talent knowledge. We also refer to this void filling idea in UAV-based talent modeling. This is because the UAV method is restricted in vegetation area with a complex talent. Here we propose an ensemble method of deep learning and the talent collection to generate the terrain with vegetation. That is, we also learn the vegetation information first, and then we conduct the terrain modeling process. Another talent modeling theory is the super resolution. Normally, it is hard for us to have the high resolution data for a whole area or a large area. But in this approach, we just need the high resolution data in several sample areas for training. Training what? Of course, the talent knowledge in this area. In addition, we also have the low resolution for the whole area, just with the similar landform type area. And then we can conduct the super resolution process for the whole area by considering the talent knowledge from high resolution data. Thus, the talent knowledge is quite important for us when we're using the AI method. Actually, we cannot simply calculate the talent information and further use in AI method. Instead, we need to understand the talent characteristic first, and then with this understanding, we can use them to guide the AI method. The last but not the least about the talent modeling theory is the value added DM. The current DM only have the elevation information. We all know that. But we believe it is not enough. As for the geomorphological analysis, 5 basic elements are needed. That is morphology, genus, materials, process, and age. Thus, we need the value-added DM data. This value-added process can be conducted from the perspective of dimension, attribute, and feature. And now we are trying to promote this research. The second research progress I would like to introduce is the telemetry analysis method. We all know that the extraction and the analysis of talent parameters has always been the core content of geomorphometry research. Up to now, hundreds of talent parameters have been proposed to describe or explore the surface morphology and process. We can find this information from different papers like the conference paper from Professor John Wilson, Geomorphometry Today and Tomorrow, or other papers. According to the frequency usage of talent parameters, the hydrological factors like flow accumulation, drainage density have been widely used. The geomorphological factors like slope, talent relief have also been used in different aspects. However, at present, these talent parameters are still in a chaotic status. It is necessary to conduct a classification system of these talent parameters. Thus, we also conduct the classification system of talent parameters, including the classes like basic talent parameters, composite talent parameters. In addition, these talent parameters can also be classified according to different analysis applications like hydrology. In addition, with these talent parameters, there's a big problem in their calculation. That is why we need these talent parameters. The parameters are not mathematical variables. They should be combined with specific geographic issues. Listen as Professor Miller published an interesting paper in ESR related to physical geomorphometry. This paper points out that the physical problem when we conduct the geomorphometry research. From my views, the physical problem should be more related to the physical process. Currently, yes, it is true that we can calculate a lot of talent parameters, but do they really relate or effectively concern the process? My answer is not enough. I just give an example. We all know flow accumulation. It can be calculated easily with JAS software, but see the figure. Here are 3 watersheds with their watershed boundary and outlets. If we calculate the flow accumulation, the value in the outlet should be the same. But if the watershed are with different gallery network, obvious, the flow power to the outlet should be different. This means that the current flow accumulation model mismatch the physical process. So we need to consider both magnitude and the direction simultaneously to better describe the physical process. So how to fix this problem? Here we propose the vector method for talent parameter calculation. This is because when we find the talent parameters, they come from the mathematical coordinate system with the property of direction. Also, the parameters of slope or flow direction or slope length have clear direction property. However, the previous talent parameters are mainly calculated by scalar method, which is difficult to consider the direction properties, resulting in the mismatch to the process model. Thus, a mathematical vector method is proposed to calculate talent parameters with a raster grid data, and the results have high precision and are stable with the change of resolution. We also use this vector method to calculate the stream power index, and we find that traditional scalar calculation overestimated the stream power. The vector approach can effectively avoid the excessively extrapolate values of stream power by considering it as a vector. The reason is that stream power should be accumulated in the same direction while being eliminated in the opposite direction. So the results show that in the ordered stream networks, the average extraction value is more than 30% in the first order of stream of the study area. But in the sixth order of the mainstream, it can be as large as more than 1,000%. In addition, we also expanded our vector method from raster DM to thin or to point cloud, since we not only have the raster data, but also other data in geo research. And we believe that the vector method has considered the direction property of talent parameters and unify the traditional scalar calculation method and improve the calculation precision and reduce the scale effect, which is suitable for DTA research of multi-data structure. And it is an important practice to solve the DTA problem by refining the mathematics. And it is expected to form a new paradigm of process-oriented DTA research. The third method is the talent feature analysis. We know that talent features are the specific talent points, lines, polygons that processing of critical significance in representing the controlling the shape of the surface. Such talent features extraction should be one of the most popular studies in geomorphometry research. But we cannot just extract these talent features. We need to further understand these talent features. So in our research, we cluster talent features for understanding or simulating the watershed evolution. In addition, we also clustered stream profile features for understanding river geomorphomic structure and evolution. This is because we believe the streams are not independent with each other, and they are linked with each other by the long node, thus it is necessary to cluster them together in geomorphological analysis. Of course, these talent features can also be used in different aspects, such as view-shape analysis, planation surface extraction in the typical plateau, and so on. The fourth method is a talent texture analysis. As we can see from this figure, this is fault, this is ridge or lowest turbulent dune. But we should ask, how can we know this landform information from only these figures? That is talent texture. So different landforms have their own talent texture, which could be extracted from DMs. Thus, with the DM data, we can calculate different talent derivatives as the textures, like slope or curvature. Then we can quantify these talent textures by different methods, and which can further be used in landform regionalization. And we believe this information presented by talent texture is the abstraction of landform from the visual level, which support the recognition and classification of landform. The last but not least about the method is the high performance DTA. As we can see from the data volume, if the DM data is 30 meter cell size, the data volume can be as large as more than 400 gigabytes. Thus, it is necessary to conduct the high performance DTA. With this aspect, we propose two methods. The first is the improvement of computing resources. That is, we need high performance computers or parallel computation method. So Professor Cheng Zhiqin also conduct different research related to parallel computation. But the second is the elimination of the calculation redundancy. Then we need to make a full understanding of algorithm in DTA through the exploration of DTA method and its efficiency issue. The reasonable calculation of talent attributes and features are realized with high efficiency, which further help to simulate the surface morphology and the geo process. The third progress is the talent application in different aspects. The first application should be the talent mapping. We use the contours, grid, or thin to map the terrain. We also use different rendering methods for mapping, as well as the hill shading method, illuminated contours, as well as the talent sketch. As for the talent sketch mapping, we can use the computer to help us to finish the sketch process because not all of us are artists. See this result. It's quite a beautiful sketch of Loess landform. The second talent application we summarize is the process modeling. Complex geographic phenomena and processes are quite related to the terrain, like debit flow modeling, flood simulation, sea level change, soil erosion, and so on. We also apply the terrain in landform evolution modeling. This is because we found an abundant ancient city near the Yellow River, which was built in Neolithic period, well abounded in Han Dynasty. Thus, after about 2,000 years of Gallic development, current landform form, therefore the ancient city information can be used as direct evidence to reflect the surface morphology before the Han Dynasty and support the current geomorphological evolution modeling. So we reconstruct the original terrain and further simulate the landform evolution process of the ancient city. We also survey the terrain change in an indoor simulated watershed by photogrammetry method, which also help in landform evolution modeling. We also conduct the landform inheritance research during the evolution process. Actually, this talk I have presented in Poland, that is Geomorphometry 2011. This is because the Loess landform is developed and evolved on the basis of underlying terrain. The morphology of the underlying terrain controls the spatial combination and the distribution pattern of the present landform. And several achievements have been made, including a book published in spring. The third application is regional studies. In the last 20 years, we have done a lot of works in the Loess Plateau. The Loess Plateau is famous for its typical positive terrains like tableland, ridge, and hill, but also for its negative terrain of Loess Garrets. Thus, all these landform units have been classified with the DM data. With this landform unit, we also investigate the spatial variation in the entire Loess Plateau in order to deeply explore the formation mechanism. We have also considered the Tibet Plateau, but we focused on the internal flow and the outer flow pattern of the basin, since the highland lakes are widely distributed in the plateau, and the Indo-Halic basin, global outflow basin, and outflow basin of the plateau exist here. Actually, the internal flow and outflow pattern of the basin varies across different scales. Thus, we are trying to investigate the characteristic of the internal flow and outflow pattern. In addition, we also propose an improved priority flood method for river network extraction in the plateau, since the traditional method like DH causes many parallel streams in the Indo-Halic basin. The third research region is the karst area in the Yingui Plateau, but we focused on the Fengling and the Fengzhong units. This is because they are the most typical karst landform with the most typical features, and it is an important symbol of the mature karst landform. Thus, we have proposed different methods like terrain openings or point clusters to extract the Fengling and the Fengzhong units and further investigate their spatial distribution. Finally, I will show some global scale application of geomorphometry research in China. The first is the global basic landform unit. The dataset uses global 30 meters DM to achieve a global classification of basic landforms. This dataset classifies the basic global landforms into two levels, the 6 and 23 categories. The paper has been recently published in ESSD. With the global landform in land area, we also achieve a global submarine landform, use the global 500 meters DM to achieve a global classification of submarine landform. Since the resolution of the submarine DM is low, We also use previously mentioned super resolution method to reconstruct high resolution data of the submarine topography for global mid-ocean reefs. And we find that the complexity of the previous terrain environment is underestimated a lot. Very interesting application in the global scale. The last part I would like to quick talk is the perspective. So as a scholar in geomorphometry, we need to consider that what is the next step of DTA research. And my first choice is geoscience-oriented DTA, or specific in geomorphology-oriented DTA. Actually, the science of geomorphology pay attention to surface morphology, formation mechanism, spatial pattern and variation, and also evolution process. However, the current DTA research mainly concerned with the terrain modeling, terrain derivative calculation, terrain features extraction, terrain mapping. This DTA research can only meet the need of surface morphology. So what's wrong? We believe is that lack information about the surface materials. Then we cannot effectively research the formation mechanism. Lack the information about the time, then we cannot effectively research the evolution process. Lack the analysis method from local to global, then we cannot effectively research the spatial pattern and variation. Thus, we propose three research contents related to this concerning. The first is understanding geomorphology ontology and the research framework of DTA-oriented geomorphology. And the second is value-added DM data model, especially with the help of GIS. The third is DTA method towards to geomorphological process and mechanism in micro scale. That is terrain texture, point cluster, line cluster, landform classification, or other, as well as landform evolution. Then we can expect to achieve a new theory and method of DTA research for geomorphology. And in the last several years, in our group also published several review papers related to geomorphometry. There are some different thinking about the research perspective. But today I would like to emphasize is that the DDE, that is the Deep Time Digital Earth. Currently, the Earth Science Research, the Earth Science Research Direction has been updated from Digital Earth to Deep Time Digital Earth. The detailed information about DDE, you can scan this QR code. That's the website of the digital Deep Time Digital Earth. Surely, we need to understand the Earth process from different time scale. So I believe the process-oriented DTA should have a position in this new Earth Science Research direction. Finally, I would like to make a brief summary of my talk. The first is DTA should be a hotspot with the development of geographic information science. It is also an interdisciplinary research field of remote sensing, GIS, resources, geomorphology, and even entire geoscience. The second is GIS-based DTA research has greatly changed the traditional research of geomorphology from the perspective methodology, which also provide a new idea for analysis and mapping of landform. On the contrary, landform analysis and mapping from regional to global also put forward new requirements to us, which need to be further studied. And third, the proposed new theory in terrain modeling and new method in terrain analysis and a new exploration in terrain application greatly enrich the current DTA research from the perspective of research accuracy, depth, breadth. This innovation can be used in micro or global landform analysis. And I also suggest that we need to join the DD program, which can help to form a new paradigm of geomorphometry. Okay, finally, thanks for listening, and I hope you can understand well. And also, I would like to say that because I'm the associate editor of ESPR, that is Earth Surface Process and Landforms. I would like to encourage our colleagues, all of you. You can organize a special issue in this journal. And also, I'm the editor member of IJGIS. Both these two journals are quite good journals. So I would like to invite all of you, if you want, you can ask me, we can discuss the details about the special issue. And thanks for listening. And I hope you can understand well. Thank you.
Thank you very much for this interesting talk. So we have a lot of hands clapping in the chat. It's now time for the discussion. So you can raise your hand or unmute yourself and ask your questions. You can also use the chat if you'd like, and I can convey the other questions.
Should I need to stop the sharing my screen?
Yes, please. You can stop the sharing.
Okay.
So we have a first question. Messi, you can go ahead and unmute yourself.
Okay, thank you. Okay, somebody has to start, so I'll do it. I wanted to ask our presenter about if he can elaborate a bit more on the vector method for calculating surface parameters. I'm wondering if this is a something more related to calculation, like, I don't know, intermediate layers, so that you in each layer you store vector information, then you come up, and then at the end they collapse in one layer only. Or I'm sorry, I'm not familiar with this method. So or is this more a different conceptual method? If you can say something more about this vector method.
Thanks for your question. Actually, about the vector method, that's an extent in our research, because this research direction just start from 2022. Because we try to do some flow accumulation work, like soil erosion work. They use slope length, they use slope, but they only use two different layers and combine these two layers together. But we believe that this kind of simple combination is not enough, because the power will be eliminated in the opposite direction, but will be accumulated in the same direction. So from my point of view, if the calculation method just simply combine the layer, the result is, from my aspect, is not correct. So I just do an experiment about stream power index calculation, because stream power index relate to flow accumulation and relate to slope, and this flow accumulation relate to flow direction. So two different directions combined together. So they should have different operation for this. So with this brief idea, and so I asked different students to use the vector method. Because previously we use scalar method, but I believe the vector method, from the mathematical views, it is more reasonable to calculate these parameters and combine different parameters together, especially these parameters with clear direction property, like slope length, aspector, or slope, or flow direction. So we also have different paper. There are more detailed information related to this vector method, and you can try to download and check the papers. That's my thank you.
Thank you. We have a question next in the chat from Ian, who asked, can you explain the exaggerations of stream power from use of scalar rather than vector methods?
Okay, maybe I need to share my screen again and let you know the extrapolation, how many has been extracted. Here, this one. Yeah, because that's the stream power simulation. If we use the traditional method, we all can calculate the field accumulation, and we also can calculate the slope. So that's the simple stream power index calculation method. But if we use the vector method, uh, maybe in the slope and hill slope area, you cannot find much difference, but in the gallery area, the difference is quite obvious. The first order stream, it can be extrapolation more about 36%. In the second order, more than 100%, especially in the mainstream. And the extraction can be as large as more than 1,000. So that's the result. But this paper has not been published because we just we submit this paper to IGS and it was under review. And there are two reviewers give us very important and very positive comments. So which means we need both consider the magnitude and also we need to consider the direction. So we combine these two factor or these two attributes together, then we can use this talent information or talent parameters with other process-oriented geomodeling. That's our understanding about the vector method for talent parameter calculation.
Thank you for that answer. There are a couple comments in the chat about references. So if you'd like, you can share with us a few references from your talk, and we can distribute them to. We can make a blog post actually on our website and share the references from your talk.
Yeah. I think you always share the video in YouTube. So this paper information you can find in this.
Yes, you're right. And I also, Carlos, put your ORCID profile with your publication in the chat. So next we'll take a question by Chin.
Okay, thank you. Thanks for your presentation, Liang. It's very informative, and I can see many listeners feel very curious on your vector-based algorithm. Same for me. So my question is also about your vector algorithm. From my feeling, I feel that it seems like your vector algorithm, it seems like very similar to some Turing analysis algorithm based on TIN. But here you may use the vector to calculate Turing attributes based on grid DM. So from my feeling, it seems like move from the TIN to those grid data structure, but use a very similar vector calculation for Turing analysis. So I'm not sure, am my understanding is correct or not? Can you clarify it a little bit? Thank you.
Yes, actually, from the beginning of our research group to conduct the vector method, someone also a little bit confused between the vector method and the vector data. Actually, that's not the same thing. Because in mathematics, there are different, there are too many operation methods. The scalar method and the scalar operation and vector operation. They consider each parameters as a vector. So this vector is not related to the data structure, but we can use this vector method in this different data structure. So this kind of mathematical operation principle is not related to the data structure, but this kind of mathematical operation principle can be used in keying in point cloud or in raster data. So I would like to suggest is that we need to learn something from different subject or different discipline. This vector method is just I learn something from mathematicians, mathematics. So I just hear their talks and I said, oh, internally they said we also can use this kind of mathematical vector operation method. So we use them, and the result is I think it's a little bit good, because we all know that the stream power, like a stream power as an example, in the same direction the power should be accumulated. In the opposite direction, the power should be eliminated. So that's the physical understanding about the research. And also there are reviewers point out a problem because I don't have true value. I cannot try to. Yes, that's true. I don't have the true value, but from the physical process understanding, that's right. Because in the same direction should be accumulated. In the opposite direction, it should be eliminated. So I just can evaluate the result. Yes, true. I don't have the true value. So I just from the physical understanding of the method to prove that this method is reasonable, it's okay. That's my response. Thank you.
Okay, thank you. Maybe some artificial surfaces can help that. And thank you. And also, I will write a paper for details. Thank you.
Thank you.
Thank you. Hannes, you want to go next?
Okay, thank you. Can you hear me?
Yeah.
Yeah, okay, good. I had a question. Thank you. I was really interested to see your global relief map, relief classes data set. Really interesting. For me, the big question here is, why did you work in 3857 in Google Mercator? Or did you do all the calculations in something else and then afterwards transformed it in 3857? It was new for me that people are working in Google Mercator.
Yeah, actually, also not only Google Map, and also in the E3 there are different global scale map in their platform. But for this map, it's a little bit different because we classified plains, hills, mountains, and about 6 and 23 categories. This kind of classification is based on our understanding. Also, and there reviewers point out the problem that it is not basically landform, it is the relief class. So I know that, but from my point of understanding, I respect the reviewers' comments about it is not landform, it is relief. But the boundary, some part of the boundary is the relief, but most part of the boundary between different landform is the sudden change area of the terrain, like galleries, like other clear boundary. So we use the 30 meters DM data. Actually, because we have a big group, we have 5 teachers and more than 50 students. We spend almost 2 months to do this work, because 30 meters DM data is quite more than I remember it's more than 400 gigabytes. We divide the students in different groups and combine the results together. Actually, the previous, the original title of the landform is a Global Basic Landform Unit. But in the paper, ESSD, you can see here, it is a typology of global relief class derived from digital elevation model. So that's the different, it's quite interesting. So different people have different understanding about the classification results. But from my views, because we show this map to different people. We show this map not from the Geomorphometry Society. We show this map to the geologists and the geomorphologists, and just see that, well, the map is quite different with previous pixel-based or object-based, because the classification system is clear, which this classification system meet the requirement from the geomorphologists, because they want where is the plain area, where is the hill area, where is the mountain area, and is the boundary between different landforms are reasonable, and we show them, and they say okay, but the most people have different view. The most different view part is the mountainous, because we use relief to classify different, because like 4,000 or 5,000. So the result, different people have different reviews about the result. So that's my response.
Thank you.
Hannes, do you want me to read the question you put in the chat too, or we move on to a different question? Okay, sounds good. So we have another question in the chat that asks if you usually teach geography students C programming for developing geomorphometry tools, and if not, what programming languages are mainly taught or used?
I'll check. I didn't teach C programming, but I encourage them to use C programming, because in China, we always invite the professors from the computer science school of computer to teach the C programming. But I always encourage students to use the C programming to develop the tools. But the lesson in China, the students do not always use C, but they use Python. They think the Python is more easy for them to learn. But when I was a student, I use C, and I try to write the C. But now it's not easy to ask the student to learn C or C++. But most of them, they use the Python.
Sounds good. And Sebastiano in the chat also says C++.
C++ is more difficult for us. Oh.
Yes, and I know that some I see John Lindsay is in the room too. Some are using Rust. Yes, exactly. So in the chat it says "Go Rust." It's a continuing challenge to teach programming languages, I feel, for geography students and different other expertise.
So we also always invite students from the School of Computer, their student for undergraduate student, but we invite them to continue for master student and the PhD student, because they can write, their programming skill is quite good.
Yeah, exactly.
Yeah, I very much like the answer from Liang, saying that the professors from the IT department teach programming languages, and from geography teach geography stuff related. I mean, we cannot know everything, right? I mean, it's difficult. How can you program in C? I mean, you can write basic tools, but then you don't have the time to go ahead. I mean, and to do other things. I mean, it would be very much effective to have some synergy between different departments and teaching different things oriented to this specific discipline. Just a comment.
Mm-hmm.
Yeah.
And also because there are 4 years for undergraduate students, Actually, the student learn C just in the first year of their undergraduate period. But for the second year and the third year in the Department of Geography, we also have calculus to teach them Python or data structure like this, more related to geography, link the program skill and the geographic issue together to show some to teach them programming. Because also in China, we need to the student want to find job. If they have good skill of programming, they are more easily to find a good job with a high salary.
All right, thank you so much. In the interest of time, we need to wrap up. Thank you so much for this great overview of geomorphometry in China. Messi, you raised your hand, or?
Yeah, maybe at the end I can have 1 minute to say something, or now, whatever you want.
Yes, certainly. Well, go ahead.
Yeah, okay. Since we have many people from Asia joining us today, I'd like to propose something. So with Cheng Zi and other 2 colleagues from Japan, we are thinking to propose a session on geomorphometry on the AOGS conference next August in Japan. And this is the Asia Oceania Geoscience Society conference, and so we have a team of 4 people now. So it would be great if somebody based in Asia would like to join this team to propose a geomorphometry session at the conference. And maybe we can attract people and let our society known in Asia much more than it is now.
Sounds good. Thank you for.
So if anybody wants to join us, just let us know.
Yes, that's a great initiative. Thank you. Like usual, if you want to reach out to any of us, you can use the Geomorphometry email address, and we can convey the information to the entire community. We'll conclude today's coffee talk. Thank you so much to the speaker and to everyone who attended. And be on the lookout. We'll have one last one in 2025 in December. So thank you very much, everybody. Have a good rest of your day.
Thank you.